Hi, good morning, everyone. Welcome to our webinar today on an overview of the new trees and pests that have been added to the TreeAzin label. Our webinar today is being led by Monica Liedka. She's our technical sales assistant here in Canada, and I will now hand it over to her to start the webinar.
Thank you, Adriana. So as Adriana has just mentioned, my name is Monica Liedka. I am the technical sales assistant with Lalemant's Plant Care. In this webinar, we'll go over the newly registered pests on TreeAzin's label. So to start, I'll provide information about TreeAzin, its mode of action, and an overview of the newly registered pests. So many of you might already be familiar with TreeAzin, but for those of you who are not, let's spend a few slides to review TreeAzin. So TreeAzin is a systemic insecticide with an azadirachtin formulation. So it isn't a contact or a topical insecticide. It has to be ingested for it to be effective. Its active ingredient is azadirachtin, and the azadirachtin is derived from a botanical source. It was developed by the Canadian Forest Service in collaboration with Bioforest, and they still hold the intellectual property, but we have a worldwide license to manufacture and distribute the product. So TreeAzin, it can be used on deciduous and coniferous species against a variety of insect pests. So every tree can be treated as long as you are targeting a pest that is registered on the label. So how does TreeAzin work? So TreeAzin works in two ways as a growth regulator. So it will stop nymph development and also sort of like a birth control. It will reduce egg laying and viability. So once TreeAzin is injected, it moves up the tree's vascular system and translocates within the canopy. Any wood-boring larvae ingesting the product within the vascular system will not be able to molt into their next instar. Additionally, pests feeding on foliage or sucking sap from branches and leaves will ingest the product, halting their development. And this leads to reduced egg laying by female pests, and the eggs that she does lay, they will not be viable, effectively suppressing future populations. So here's the list of registered pests, with the newly registered pests highlighted with a red arrow, along with their respective application rates. So they include all Agrilus beetles, including two-lined chestnut borer and bronze birch borer, all aphids, including linden aphids, brown-tailed moth, and beech leaf mining weevil. So for each of these pests, I will provide a detailed overview covering their origin, appearances, preferred host plants, life cycle stages, including the corresponding signs and symptoms, recommended application rates for treatments, and the best timing for implementing those treatments. And this comprehensive overview aims to equip you with the knowledge needed to successfully manage and mitigate pest infestations. So let's start with the Agrilus beetles. So this is a list of all Agrilus beetles currently found in Canada. Agrilus beetles have this metallic sheen, which can range from a green, sometimes like blue, or even a bronze, which is a very distinctive feature of many members in this genus. Agrilus beetle family includes the emerald ash borer, as well as other notable members such as the two-lined chestnut borer and bronze birch borer, which will be the main focus of today's discussion. So let's begin with the two-lined chestnut borer. So this native species is distributed across various regions of Canada, particularly in areas where its host trees are prevalent. Its presence is documented in parts of Ontario and Quebec, where suitable oak and hardwood forests are present. Additionally, it may also inhabit other provinces with similar habitat characteristics. So the adult borer has a similar metallic appearance to emerald ash borer, measuring approximately 8 to 13 millimeters in length. It is dark colored with two distinctive pale to golden brown stripes along its back. And those two stripes, that is its key ID feature. And as a secondary pest, this borer is attracted and drawn to trees that are already stressed, weak, or injured. And it primarily targets various oak species such as bur, swamp, white, chestnut, and red, along with other hardwood trees such as hickory and beech. So next we'll have a look at the two-line chestnut borer's life cycle, which will help us to identify what signs and symptoms to expect from this borer. And by understanding the life cycle, we can determine optimal timing for implementing treatments, ensuring effective management of infestations, and mitigation of damage. So the two-line chestnut borer generally has one generation per year. As temperatures start to warm, the adults they become active and will emerge from their overwintering sites as larvae. And this emergence period typically occurs in May to June, although it may vary by location. And this is a good time to look out for small D-shaped emergence holes left by the adult beetles. Throughout the summer months, from June to August, the beetles will feed on foliage and begin to mate. However, their main goal at this stage is reproduction and egg laying on the bark of their host trees. And although they feed during this time, their feeding activity does not typically cause significant damage. Within approximately 1 to 2 weeks, the eggs will hatch and the larvae will burrow into the tree's cambial layer. And as they feed, they create tunnels or galleries, disrupting the flow of nutrients and water within the tree. And it's this feeding activity that does the most damage, weakening the tree and causing symptoms such as discoloration and wilting, leading to browning of foliage in specific branches or sections of the canopy. And the location of canopy damage, that can vary depending on a range of factors, such as the distribution of the larvae, the extent of the feeding, and also overall health of the tree. And as summer transitions to early fall, so from August to October, the larvae will have gone through 4 instars and undergo pupation within the individual chambers in the outer bark or sapwood. From October to January, the pupation is complete and the larvae transforms into adult beetles within these chambers. Some adults, they may emerge during this period, while others may remain dormant until the following spring. And if they do emerge, they'll seek overwintering sites to survive the winter months. And then come springtime, the cycle will continue. So it's important to note that symptoms of two-lined chestnut borer can often be mistaken for those of oak wilt, and it is not uncommon for trees to be affected by both simultaneously. Therefore, it's crucial that you thoroughly inspect for all signs, including the galleries, the D-shaped exit holes, and also the frass to confirm the presence of this borer. And as we know, two-line chestnut borer is highly damaging and poses a significant threat to oak trees, particularly those that are already stressed by factors such as drought or other insect attacks. And of particular concern are oaks that have been heavily stressed from multiple years of spongy moth outbreaks. And previous two-line chestnut borer outbreaks have also followed cankerworm defoliation of oaks. So up next, we have the bronze birch borer. The bronze birch borer is a native species to North America, and true to its name, the adult beetle typically exhibits a bronze colorization, although it can also appear as a deep olive green. Males measure between 6 to 9 millimeters in length, while females range from 8 to 12 millimeters. And the bronze birch borer targets native birch species like white and yellow, but it can also infest introduced birch varieties. It is also important to note that white-barked birch trees are more susceptible compared to other birch species without white bark. And some reports have also stated that this beetle has been found in stands of beech and aspen. And similar to the two-lined chestnut borer, the bronze birch borer primarily attacks trees that are already weakened or stressed, and repeated attacks can result in localized areas of damage or even complete mortality, depending on the condition of the tree. So moving forward, let's explore its life cycle. So bronze birch borer generally has one generation per year, although in northern regions, the cycle may extend over 2 years. So during early spring, April to early June, adult borers will emerge from overwintering sites, leaving behind that distinctive D-shaped exit hole. And they typically do not eat foliage, but instead will seek out a birch tree for mating and reproduction. And the female will lay as many as 75 eggs over her lifetime, depositing them in cracks and crevices in the bark of the tree. In summer, June to August, the eggs hatch and the larvae will burrow into the tree's phylum and cambium layers. And this activity results in the creation of zigzag tunnels or galleries beneath the bark, which is visible on the tree. And this feeding does damage by disrupting the flow of nutrients within the tree, leading to stress and decline. Symptoms of crown dieback will typically progress from top down, characterized by yellowing, sparse and wilting foliage, and the tree will retain some leaves, and the appearance of epicormic shoot growth is also common. Without intervention, twig and branch dieback will occur, further weakening the tree with the risk of complete mortality. As a defense mechanism, the tree may even attempt to form callus tissues around the larvae galleries. And in some instances, this process can stop the larvae from expanding, feeding, and completing its development. And this callus will appear as a swollen bump, which serves as an indicator of the tree trying to combat the infestation. By fall, September to November, the larvae will have gone through 4 instars and begin to pupate within the tree. And then throughout the fall to winter months, the larvae will undergo transformation into adult beetles within the pupal chambers. And then come springtime, the adults emerge and the cycle will repeat itself. So mortality can occur in a year under hot and dry conditions, but generally it does take several years before the tree's mortality. So the application rates for all Agrilus borers, including the 2-lined chestnut borer and bronze birch borer, is 5 milliliter per centimeter DBH. The number of applications is once a year on a biannual interval. And considering what we have learned in the previous slides, we know that the borer is active from late spring until September before becoming inactive. So the application window can vary depending on your region, but generally it spans from May to September. And it's also critical that you do follow the label and you treat post-bloom, meaning after the flowers have dropped, to avoid impacting pollinators. So shifting gears, we'll now have a look at the beech leaf mining weevil. So the beech leaf mining weevil is a non-native invasive species that was first confirmed in the Maritimes in 2012, specifically in Halifax, Nova Scotia. Its native range is in Europe, and it's also known as the beech flea weevil due to its remarkable ability to jump great distances. And this adult weevil is black with golden hairs, reaching sizes of up to 2.8 millimeters. And as its name suggests, this weevil exclusively feeds on foliage from American and European beech trees. So the spread of this weevil is ongoing, and researchers have found mortality as high as 88% in stands where the weevil has been present for 6 years. So this really highlights the significant impact it can have on an affected ecosystems over a relatively short period of time. Now let's turn our attention to its life cycle. So beech leaf mining weevil completes 1 generation per year, but there can be 2 adult population peaks, one in May and the other in June. So during springtime, April to May, as the temperature starts to rise, adult weevils become active and emerge from their overwintering sites from cracks and crevices of bark and in the leaf litter. And once emerged, females begin feeding on new beech foliage and mating. And the adult causes damage referred to as shot holes, which resembles small pinholes throughout the leaf. Throughout spring to summer, May to July, the female weevils lay eggs on the underside of beech leaves, and the larvae will hatch within a few weeks. During summertime, June to August, the larvae will feed inside the beech leaves, creating small tunnels and blotch mines from the mid-rib to the leaf margin. And as they feed and develop within the leaf mines, the larvae undergoes several instars. So infested leaves, they may appear dry and wilted, giving them like a brown, crinkled, or curled appearance. And this damage reduces the tree's ability to photosynthesize, leading to decreased growth and weakening of the tree. Prolonged infestations or repeated defoliation can severely weaken and stress out the tree, which over time may lead to mortality, particularly in unhealthy trees. In late summer to fall, so August to October, the larvae exit the leaf mines, dropping to the ground to pupate in the soil, the moss, or leaf litter of the host tree. Any adults that emerge early will seek out a host to overwinter. And traditionally, beech bark is very smooth, providing very little area for weevils to overwinter. However, with the introduction of beech bark disease, weevils are attracted to that rough bark. From fall to winter, October to December, the pupae remain in the soil or leaf litter, undergoing metamorphosis into adult weevils. And then come spring, the cycle will continue. So application timing is 3 milliliter per centimeter TBH for annual applications when there is a severe infestation, or 5 milliliter per centimeter DBH for biannual applications for lighter infestations. And you want to apply in spring, April to early May, or fall in October. So now let's shift our focus to the linden aphid. So the linden aphid is non-native, originating from regions in Europe and Asia where linden trees are present. And these aphids are small, typically measuring 2 to 4 millimeters in length. And like other aphids, they have a plump body. They've got those long antennae and also some pretty slender legs. Their appearance may vary depending on their life stage, but generally they are this pale green, yellow, or even like a light brown, often exhibiting markings on their bodies as well. Their primary host is the linden tree, but they will also infest lime trees in their native range. And it is not common for a linden tree to die from linden aphid damage alone. However, prolonged infestations can weaken the tree and make it more susceptible to other stressors. Now we'll have a look at the life cycle. So depending on environmental conditions, linden aphids can have multiple generations a year, often with a spring, summer, and fall generation. So in spring, April to May, the overwintering eggs hatch into crawlers. And these crawlers are mobile, actively seeking feeding sites. And they feed by inserting their mouth parts into the underside of linden leaves, extracting sap. And this feeding activity results in yellowing or stippling on the leaf surface. And additionally, as the population grows, leaf curling, again, yellowing, or discoloration may become evident. During summer, from July to August, the nymphs will mature into wingless adult females, which continue to feed and reproduce asexually. And when the aphid population is high enough, you may start to notice the secretion of a sticky substance known as honeydew. And this honeydew can become a nuisance by coating cars and even hard surfaces, attracting ants or wasps. Additionally, it provides a medium for the development of sooty mold fungi, which covers the honeydew, giving it sort of like a gray to black appearance. And sooty mold is primarily an aesthetic concern, but it may also impede photosynthesis as it accumulates and hardens over time. Towards the end of the season, August to October, a fall generation of winged females emerge. And these females mate with winged males and have the ability to find new hosts and lay their eggs. They'll start to lay their eggs in crevices, in twigs, and also on branches as well. From fall to the end of winter, October to March, as temperatures start to cool, the overwintering eggs enter a dormant phase, and they remain dormant until the following spring when they're ready to hatch. And then this ultimately restarts the population cycle. This is just a reminder that all applications must be made post-bloom. It is worth noting that linden trees are among the last trees to bloom in the season. Therefore, applications for treatment against linden aphids will occur between late June and early July. And as we've learned from the previous slide and from the life cycle, the application timing is post-bloom to September. Applications are made once a year on an annual basis with a rate of 3 milliliters per centimeter DBH. Lastly, we have the brown-tailed moth. So the brown-tailed moth is a non-native and invasive species. Its native range is in Europe. It is found in northeastern United States and in the Maritimes in eastern Canada, specifically in Nova Scotia and New Brunswick. And while it hasn't reached Ontario just yet, it is something to keep an eye out for. So it has a distinctive appearance, both as a caterpillar and adult. The caterpillars are dark brown with a white stripe on each side of its body, along with 2 red spots. And they're also covered in these red to brown hairs, which actually pose a health risk. So these fine hairs are irritating and can cause a skin rash very similar to poison ivy. Additionally, these hairs, they can also become airborne and lead to respiratory issues. The adults are only seen in summer from July and August, and they're entirely white with brown to orange hairs on their abdomen. And similar to the spongy moth that we are familiar with, the brown-tailed moth causes significant defoliation of trees and shrubs. Common host species include oak, hawthorn, birch, willow, and apple. Their feeding behavior can cause reduced growth and branch dieback, and repeated infestations have the potential to lead to mortality of trees and shrubs. Now let's turn our attention to its life cycle. So the brown-tailed moth has 1 generation per year and undergoes 4 life stages: egg, larvae, or caterpillar, pupal, and adult. So beginning in early summer in July, adult moths will mate and lay eggs in sheltered locations. In August to September, the eggs hatch and the larvae emerge hungry, and they'll begin to feed on foliage, causing defoliation to the tree. And this feeding activity results in the gradual thinning of the tree's crown, leaving that bare tip and branch look. The larvae stage lasts from August through to the following June. In the fall time, September to November, the caterpillars will construct a webbed nest using leaves tightly wrapped with silk. And these nests can contain up to 400 caterpillars, and they serve as a protective shelter throughout the dormancy period, which spans from late fall to early spring. And then they will remain dormant throughout the winter months. With the onset of spring and the emergence of new leaf buds, the caterpillars will resume their feeding activity on fresh foliage, and they'll continue to grow through the spring months before pupating in June. And as July approaches, the adult moth, they will emerge and the cycle continues. So application timing is spring, April to June, as soon as the overwintering caterpillars are emerged, or from late fall, October to early November. Application is to be done once a year on an annual basis at a rate of 3 milliliters per centimeters DBH. So up to this point, we have covered when to treat, but now let's talk about when not to treat. So something to remember is that not every tree is treatable. So this chart shows the canopy dieback of an ash tree over time. Obviously, you won't be treating a tree that has a 90% canopy dieback just because they won't have the necessary vascular system to effectively draw the product up into the canopy. So the limit for canopy dieback when treating any tree is usually 30%. Anything more than 30% might compromise treatment effectiveness. And this is a bit tricky because 30% for one person might not be 30% for somebody else. So it can be pretty subjective. And it's also worth noting that dieback can also happen very quickly. So sometimes we can assess trees in June and know that they have a 30% dieback. And when we arrive to treats in late July or early August, for example, that tree now has a 60% crown dieback. So it can happen very quickly with certain pests. And it's also important to remember that it can also depend on other stressors that the tree might also be experiencing. So when a tree has lost about 30% of its foliage, we consider that that tree is no longer treatable just because the vascular system of the tree has already been overly compromised, and whatever you're injecting at the base won't be able to make its way up to the top of the crown. So in an ideal world, we would be treating trees at the 0 to 10% marker, and that's where we'll see the best results. So to conclude, application rates can be found on TreeAzin's label, and the dosing rate table is found in the EcoJect Assistant Manual. Applications must be made post-bloom. Keep in mind that linden trees are among the last trees to bloom in the season. And treating a tree with more than 30% canopy thinning and or dieback may compromise treatment effectiveness. So this concludes the webinar. Again, thank you so much for joining. I also have my colleague Elsa on the line here with me, and we're happy to take any questions.
Yeah, thanks, Monica, for that informative presentation. Yeah, we have just about a minute or two left. If you'd like to ask a question, please post it in the Q&A panel.
So Dane asks, are there any weevils that are any other weevils that are treatable? So at this point, only the beech leaf mining weevil is on the label. We have done some work, some trial work on white pine weevil, for instance, but unfortunately at this point, it is not yet registered. So actually, I'm going to correct myself. We have beech leaf mining weevil, but we also have the red elm bark weevil as well. Those are the only two weevils on the label. Good question.
And then we do have a question from Kevin. Birch tend to bleed sap. If TreeAzin is injected, will it not enter the sap?
So good question, Kevin. So the whole point of injecting is for it to enter the sap. So we want the TreeAzin to be taken up into those conductive tissues where the sap and all the water and nutrients are being taken up. So that will tell us that it's being taken up into the canopy. So I hope that answers your question. Okay, we have another question from Brian. How long can TreeAzin be frozen? Excellent question, Brian. We typically recommend that TreeAzin be frozen just overwintered for one season, for 1 year. Anything longer than that, we can't speak to the product's viability after that.
For borers, is it an annual treatment or biennial?
Yeah, so for flat-headed borers, all the Agrilus on the label, similar to EEB, but for two-line chest borer and bronze birch borer, we recommend a biannual treatment, so once every 2 years. Again, it depends on pest pressure. So if you notice that the following year or the year following the injection, the pest pressure is still high, you can always apply again in the following year. But our recommendation is every 2 years.
That will wrap up our webinar for today. If you do have additional questions that were not answered in this webinar, feel free to contact Elsa or Monica directly, or you can also contact us at our support email or our toll-free number, which is shown on the screen. So thank you everyone for taking the time to join us, and we hope that you have a great day. Take care.